Hi, welcome to the dynamics tutorials. So with this problem we're going to be looking at a mass that's undergoing translation only, but it's also going to be moving with curvilinear motion. We're going to find the reactions and also the acceleration of the center of gravity of the mass. So mass AC is supported here. It has a mass of 50 kilograms and it's connected with a massless link AB and a massless link CD. These two massless links are 2 meters in length, and then they're also 1 meter up from the center of gravity in the y direction. The system is given an initial velocity here, given by the omega AB, also omega CD, of 1 radian per second, and that's in the counterclockwise direction. Note that omega AC is 0 and that alpha AC is 0 because even though this moves, this beam stays right side up, so it never rotates, it only moves in a circle. Let's draw our free body diagram. So we have our weight that's acting down, we have our force from AB and our force from CD. Because we're moving around in a circle, let's use normal and tangential coordinates. So normal moves is directed in towards the center of the circle. So N would be going in this direction. T would be going in the direction of the motion. So when we do our sum of forces normal, it's going to be equal to the mass times the acceleration in the normal direction. Remember that there's two options. You can use v squared divided by the radius of curvature for AN, or you can use omega squared r for AN. Either one is going to give you the same answer. You would have to calculate V as omega times r, and so V squared would give you omega squared times r squared divided by r. And that'll give you the same thing as omega squared r here. So we'll plug this in and we'll get that FAB plus FCD is equal to the mass, 50 kilograms, times the 1 radian per second, that quantity squared, times the 2 meters, and that'll give us FAB plus FCD is 100 newtons. Then in the tangential direction, we have the weight going in the positive tangential direction, so 50 times 9.81 meters per second squared is equal to the mass, 50 kilograms, times the tangential acceleration. So the tangential acceleration is 9.81 meters per second squared. We can then calculate the magnitude of the acceleration as the 9.81 meters per second squared, the quantity squared, plus the 2 meters per second squared from up here, the 1 squared times 2, the quantity squared, add them together, take a square root, and we get 10 meters per second squared. And then now we can do the sum of moments about the center of gravity is equal to IG alpha. Really important to recognize here with this one though, alpha of the body AC, is 0. So even though alpha of AB is non-zero and alpha of CD is non-zero, the body here never rotates, so its alpha is 0. So this winds up being 0. So we have FAB times 1 meter, that gives us a negative moment. FCD times 1 meter gives us a positive moment. That'll give us FAB is equal to FCD. Plug that in up here, and then we get that both FAB and FCD are equal to 50 newtons. Thanks for watching.